Sqoop. We have already completed our pick. We have already completed Hive. In Hive, we have to start with this dynamic partitioning. Okay, we are yet to start with this dynamic partitioning concept. So before going into that, today let me start the scope. Also, because for working with this dynamic partitioning, we want to bring some data. Okay, so from your RDBMS, our use case is dealing with this, so bringing some data from RDBMS into your Hadoop file system, and from that we using this dynamic partitioning concept, we create a table. As of now, we have already discussed in terms of Hive. There are two types of table. One is managed table and another one is external table. So far we have discussed about the concept behind the managed table and external table. Under these two, we have a static table and a dynamic partitioning table. So we have a partitioning table and a non-partitioned table. Here too we have a partitioned table and a non-partitioned table. This dynamic partitioning is pertaining to the external non-partitioned table. So far we have discussed about the differences between managed table and the normal external table and partitioned table, then how it will be partitioned, what's the advantage of going for this partitioning, and then clustering concept, everything that we have completed. We have to complete this part only, the external non-partitioned table and the external partitioned table. Okay, for that we make use of the concept called dynamic partitioning. So the practical exercises that we are going to make use of it, we want to create some data, and then data need to be crawled from these data sources using Sqoop. Therefore, today and tomorrow, let me complete this Sqoop and let me continue with this dynamic partitioning once the Sqoop has been over. Okay? Yes. So I think so all participants have successfully configured a big Hive in your system. If not else, you please kindly configure with Hive and Pig. Okay. So today let me start with this scope. So here you have data stored in HDFS. This is your Hadoop distributed file system, under which you will be having your multiple data nodes. Okay, data node 1, data 2, data node n. Here you have the data. Then you want to write a map reduce program, as you know. What thing that we are discussing is with respect to Hadoop 1.x. Hadoop 1.x supports only map reduce programming alone, whereas Hadoop 2.x it supports a multi-tenancy support. If it is 2.x, you can have a map reduce program. You can have a online real-time processing. You can have a graphical processing like this. You can have multiple applications that may be run concurrently on top of the data stored in HDFS. It is in Hadoop 2.x, and this property has been termed as multi-tenancy. We have already discussed about this multi-tenancy. Okay. So whereas here in 1.x it allows only map reduce program only. So here what we did, we make use of the concept of ecosystem tools like Hive or Pig. Under Hive, user will interact with this Hive using a language called as HiveQL, Hive Query language. And under Pig, user will have interaction using a language called as Pig Latin. Then we call Hive as a data warehouse language, Hive as a data warehouse language of Hadoop, whereas we call the Pig as a data flow language. Okay, these are all some of the things that we have discussed. So to bring the data, how you can bring the data? Through this HDFS client. Okay, if a user want to submit some data, we have a computer called as HDFS client. Through that, user may bring the data. Okay, we have already discussed about how to read and how to write a data file in HDFS in our initial theoretical discussion itself. So once your data is placed here, your data may be placed in your either in your local file system or in your HDFS file system. You know the difference between your local, that is your Linux file system, and the HDFS which is mapped on top of your local file system. Okay, so if your data has been already placed, you can write a Hive script or Pig script to access the data through this internal map reduce program. Okay, how if you can also bring data from different data sources. Example, let me imagine you have a data source, RDBMS data source. Let may be a Oracle database. You may have a data crawled from a data warehouse. You may have a data warehouse. Or you may crawl data from social networking sites like Facebook or Twitter like this. Those data, these are all structured data. Data you crawled from this RDBMS, data warehousing and structured data. They are all either unstructured data or it may be a semi-structured data. You can have a flat files. You can take these flat files. These are all the different data sources that you can make use of. Okay, these are all different data sources. So you want to bring the data. So this RDBMS database, here it is a OLTP transaction. Each and every day, some transaction is happen in the database, and the database will be populated. If you want to do some analytics on top of its data, the RDBMS data, the data need to be brought into this HDFS. Okay, for analytics, it need to be stored in the HDFS. After that, using Hive you can write the needed business logic, and you can able to do some analytics on top of it. Either you can use Hive or you can use the programming languages like R, or you can use a framework Spark combined with Scala. We will have a discussion of all those things. These are all the R, Spark, Scala is most widely used for data analytical purpose. Okay, so even the analytics can be done using Hive or you can directly write a program in Java, or you can make use of a language which is most widely used, Python, to write the MapReduce to do the needed processing. But the data need to be brought into the HDFS for processing. So who is responsible for bringing the data into the HDFS? For that, we have a component called as Sqoop. Sqoop stands for SQL to Hadoop. We call this Sqoop as a SQL to Hadoop, which is especially meant for transferring data from RDBMS data sources. That is, to transfer this structured data, to fetch that structured data from the RDBMS data sources into the Hadoop file system for analytics. We make use of Sqoop. So similar to that of Sqoop, we have some other tools called Flume. We have tools like Kafka. These are all covered in our curriculum. Okay, what's the use of Flume? If you have data, the data is unstructured or semi-structured, you can make use of either Flume or Kafka. Okay, so the Kafka and Flume are those tools which is used more specifically for crawling data if it is unstructured or semi-structured. So in our example of our discussion of Flume, we will have a discussion. We will create the user account in Twitter, and we will crawl the current tweets according to some current trending that is going on, and we do crawling of Twitter data, and we place the Twitter data in HDFS, and using either Hive or Peak, we can do practice sentiment analytics, another use case, what people are thinking about. For example, today, so this National Democratic Front has announced the Bihar governor as a presidential candidate. So Congress announced Meera Kumar as the presidential candidate. So out of these two, which is having support from people? If you want to make a tweet, okay, people may express their views, opinions in Facebook or Twitter. What we can do, if you want to do analytics, what sort of analytics that you are interested here, you want to find out. So who out of these two, this NDA and Congress announced candidate, so who will get the maximum support in terms of people's perspective? If you want to do, then you need to crawl data from Twitter and Facebook, and you need to write some business logic, analytic logic, which let you know sentiment analytics that we will discuss. Okay, in our use case, we have a use case sentiment analytics, which is written using, which can be written using Hive, Pig, or Java, anything. In our use case, I think so. We are going to make use of Pig for sentiment analytics. So that is one use case associated. So now the intention of today's session is we are how to crawl the data from the data sources. For this, we are going to make use of creating a MySQL table, and we populate some data into the MySQL table. From the MySQL table, using this Sqoop, we can able to bring data into HDFS, and we can able to query data using Hive, Pig, or any other thing. That is our intention. Okay, the Sqoop, it is a tool which is designed to transfer data from the RDBMS sources into the Hadoop distributor file system. Okay, so it support not only MySQL, it support all the databases, RDBMS databases. We can able to crawl data from an Oracle database. You can able to crawl data from Oracle database. You can crawl data from MySQL. You can crawl data from SQL Server. Anything that you can like. Okay, what are all the RDBMS? It support that RDBMS. But if it is unstructured data like Facebook or Twitter data, it won't support. For that, you need to go for the Flume or Kafka. For real-time data crawling, if you want to crawl some sensor data, okay, you want to find out the minimum and maximum temperature for a particular city. Let me take a Bangalore city. So thousands of sensors might have been incorporated in the Bangalore city. So sensor will produces streaming data continuously. If you want to crawl the sort of streaming data, you need to go for this tool Kafka. Now we have another most widely used Apache Nifi for data crawling. So several companies start using Apache Nifi. So these are all some of the data crawling tools. The standard tools are Sqoop, Flume and Kafka. So our curriculum deals with the Sqoop and Flume. Okay. If time permits, I will let you know the Kafka. So this is the overall view of what Sqoop can do. So you can do two activity. One, you can bring the data from SQL into Hadoop. That is your RDBMS. Rather than saying SQL, from relational database management into Hadoop. Then once here in Hadoop, it will be placed in HDFS. Once the process has been done, you can store back the data from Hadoop file system into your RDBMS. So for doing these two sort of activities, bringing data from your RDBMS and after performance of all those things, getting back the data into RDBMS from HDFS can be done in two ways. One, by using utility called as import. The import utility is used to transfer data from SQL to Hadoop. Then the export is a second utility. This export utility, which is used to transfer data from HDFS back to RDBMS. Please make a note of it. These are all the utilities that we are going to discuss today. Okay. So you have RDBMS. You have this Hadoop distributed file system. You are already aware of what is HDFS, which is nothing but the data nodes. You can use this tool import and you can use the tool export. Import is used to fetch the data from RDBMS to place the data into HDFS. Reverse is export. Export is used to fetch the data from HDFS to place the data back to RDBMS. Okay, so these are all the use of import and export. Here, not only in HDFS, you can also store the data from RDBMS into Hive. You can also store the data into HBase. You can also store the data into other databases like MongoDB, like external NoSQL databases. Okay, so not only to HDFS, you can store the data to directly to Hive, directly to HBase, directly to NoSQL database like Mongo. Please make a note by using this tool, Sqoop Import. Here, the data that it is stored here, RDBMS is a structured data, but whereas when using this import command, if you store the data here, the data will be stored in forms of a text data. Okay, so you are already aware of. So you can store in text data, or if it is a audio video, you can store it in some other format for binary, or we can have, if it is a streaming data, we can have other format like Avro format. We have a sequence file format. There are several ways by which you can store the data. But this is the default. That is storing data as a text format is by default. We practice this thing and these things according to our requirement. Okay. Actually, the files in file format only data will be stored. Okay. So with this introduction, let me start with the Sqoop installation. The prerequisite exists. Okay, so we are going to work with this single node. In our practical, we are going to work with this single node. We have already discussed how to configure this single node Hadoop. So your prerequisite 6, your Hadoop need to be configured. Your Java need to be configured. Then need to configure Sqoop. On top of it, we are going to install Sqoop. Okay, Hadoop and Java need to be configured for you. So you can make a check, you can log in into the machine and you can make a check Java space hyphen version, and you can check with your Hadoop JPS. So it should run all the daemons, name node, secondary name node, job tracker, data nodes and task tracker. All the daemons should be running. Okay. These are all the ways by which you can ensure both the Hadoop is running and Java is configured. Now we are going to configure Sqoop. You are already aware of how to install Java and how to install Hadoop on top of it. So here you can make use of either version 1 or version 2. So now I am going to let you know with this version 1. The same process need to be followed for version 2 also. No need to worry about whatever may be the version. So you need to download the Sqoop. Okay, so you logged in into the single node cluster. If you type a present working directory, it will show you are currently under home/Hadoop according to our previous discussion. Here we are going to install Sqoop. For that wget, you want to type this Sqoop URL. So where to get the URL? As of our previous installation, you simply click on download Sqoop. It will take you to the Apache site, sqoop.org. Okay, you can download from any other releases. You can click on a mirror by mirror. Here you can get this any one version. Okay. This is the version 16 MB size that you need. So right click, copy link address. Okay. So you can find Sqoop -1.4.1 Hadoop 1.0 tar.gz. You can make use of this, or you can make use of this anything. Okay. So you can make use of anything. tar.gz. Whose size is 16 MB. Please make a note of this. This is the older version, Sqoop -1.4.1.tar.gz. You can also download this. Any three you can make use of it. Right click, copy link address, $prompt, wget, right click, paste. Okay, you will get this URL. So once you download it, you will be getting this file. Once you download it, you will be getting this file. Sqoop -1.4.6.bin underscore Hadoop -1.0.4. This is the file that you will be getting. Once it is downloaded, where it will be? It will be under /home/Hadoop. Under this home path, you will be getting this file. This is the home path of Sqoop. You want to specify this home path. Export Sqoop underscore home equal to, you want to specify this full path here. Under which file you need to specify? Under .basrc file. Okay, this .basrc file, where it will be? and it will be under home/Hadoop. For each and every user, you will be having a .basrc file. Under that basrc file, you open that file, you type the following thing: export sqoop underscore home equal to the full path. Similarly, you have already export path equal to, you have a $path. So before that, the file contain export java underscore home. You have a Java home path already present, and you have Hadoop home path already present. Export Hadoop underscore home. Similarly, if you have configured -b, those home path will be present. So you want to specify export path equal to $path colon $sqoop underscore home /bin. Okay, these are all the things that you need to configure. So this $path may have a, initially you may have a $path. That path may contain a Java home, Hadoop home, pig home, hive home. So either you can specify separately or you can club that thing. Okay, you have export path equal to existing path $path colon along with that $sqoop underscore home /bin. This is the thing that you need to specify here. Where under .basrc file. Please make a note. After that, what you need to do? You want to source space .basrc. Why you need to source? In order to this effect need to be reflected to this Hadoop ecosystem, that is your Hadoop kernel. You either you need to start this server, Hadoop server, else if you don't want to start this server, then here you can issue this source.basrc file, which will make an update. Then after that, you need to do one configuration file. Okay, so there will be a file by name sqoop-environment.sh, where the file will be present under the Sqoop installed location under home Hadoop under Sqoop. There will be a folder by name conf. Please make a note. There will be a folder by name conf. Under the conf folder, you won't have this sqoop-environment.sh. You will be having a file by name sqoop-environment-template.sh. sqoop-environment-template.sh. So you want to create the environment.sh file. How to create? Simply use copy. So sqoop-environment-template.sh, and this is your source file, and you are creating a copy under the name sqoop-environment.sh. This is the file you need to make a copy. So under that Sqoop environment.sh, what you need to do, you want to specify the home path of your Hadoop. Export Hadoop underscore home equal to, you want to specify the home path of Hadoop /home/Hadoop/ if it is 1.2, you want to Hadoop -1.2.1. If it is 2.x, you want to specify this time. Okay, so here this is for 1.x. If it is 2.x, you need to specify two things. One is export Hadoop underscore home. You want to specify the home path. And second thing, export Hadoop underscore mapred underscore home. Okay, the same path where you have configured Hadoop. Okay, so in your 2.x where you have configured Hadoop, that home path need to be specified. It will be /home/Hadoop, the same location, Hadoop hyphen, I think so, 2. Whatever may be the version, 2.7.3 like that. Okay, 7.3. You want to specify for Hadoop 2.x, and this line need to be specified for Hadoop 1.x. Please make a note. That is, your sqoop-environment.sh file should contain the Hadoop home path, whether it may be 1.x or 2.x. Then what you need? After that, what you need is, you need a connector. You need a connector. For each and every databases, if you are having a MySQL database, you need a MySQL connector to be configured in your Sqoop. Okay, this connector alone will let us make a connection between this RDBMS, your MySQL data source, and Sqoop. Similarly, if you are having Oracle, for Oracle, you need to download a Oracle connector. For each and every database, we have a separate connector, using which only you can make a connection between your Sqoop and the corresponding databases. Here, what you need to do, you want, being our example is going to be with MySQL, I am going to have MySQL hyphen connector hyphen Java hyphen 5.1.28.tar.gz. This is for version 1.x. 5.1.30 tar.gz if you are configuring version 2.x. Please make a note. You can directly check it with Google. You can download MySQL connector. It will let you know where to download. It will be in a repository like a GitHub, open source repository like Maven like thing. Okay. Download MySQL connectors. Okay. MySQL hyphen connector. Here you can find it. Java 5.2. So here you need 8. That's all. Okay. You can directly download from any one of the site. Maven repository. You may have a GitHub repository. You can get it from any site. Click on this. This is the connector that you need. This is for 5.1.42. We want to go with this previous repository. Let me move back. Let me take it from a Maven repository. Okay, this is the connector that we need. Simply download. That's all. Okay, 5.1.2.8. It is a general public user license, so you can download from this site. Okay. Click on and download this. Duplicate. Click on it will download this connector. You should not make any other connector. Okay, you need this connector alone. Right click, you just copy the link address, and as of wget you can connect it. Okay, download it. Then where you need to place this connector, you need to place once it is downloaded, the connector will be a zip file tar.gz. You want to untar it. How to untar? Simply type tar space -xvf. You untar the connector, then you will get a connector. So you will be getting, once it is untar, MySQL hyphen connector hyphen Java hyphen 5.1.28. Okay, hyphen bin.jar. Your jar file will be created. So where you need to configure that? So under the location where you have installed Sqoop, under home, under Hadoop, you have installed Sqoop, under which you will be having a lib folder. Please make a note. Under this lib folder, you want to copy that. Okay, so you download the connector and simply copy. You want to copy the connector under a library folder which you have configured Sqoop. Under this lib folder, you need to configure this. Then only the Sqoop can able to make a connection with the corresponding data sources. If you are going to make use of Oracle, you need to download the Oracle Connect. Being our example is going to be with MySQL, we are going to make use of MySQL connector. Okay, so if everything is okay, then you can check the scoop. The scoop is over. Then simply move to the location, CD, the location where you have configured scoop, home path of scoop. So here scoop hyphen etc. Then here what you need to do, so move to the bin folder of this location. Simply type scoop hyphen version. Okay, if everything is perfect, it will list what is the version, whether you have configured version 1 or version 2, whatever may be, that version will be listed. This is the way by which you need to configure your scoop. Yes. If you have any doubt, please let me know. The installation of scoop. Here, you do the following practice. So in your system, that is in your Hadoop single node. So type present working directory. It will show you yours under home/Hadoop. Performance. You are going to discuss how to install MySQL. Okay, you want to first perform a update. Sudo apt-get update. Then after that you need to install MySQL. Sudo, very simple command, apt-get install MySQL server. That's all. It will prompt you for at the installation. It will prompt you for a root password. Okay, what is the password for root user? You can assign any password. I am going to assign root as a password. So after that, your MySQL will be configured. Okay, you can check whether it is configured or not by simply typing system control status. System control status MySQL.service. System control status MySQL.service. Okay, so if the status is showing it is running, then that's no issue. If it is showing it is not yet started, then you need to start the service. If not, if the status is not running, you need to start sudo system control, the daemon name MySQL start. Okay, if not, okay, if it is not in running status, you want to start it explicitly. So then the service will be started. So after that, you need to make a connection with this MySQL. How to make a connection? Simply type MySQL -u root then -p. Okay, so it prompts you for a password. Then you want to type this password root, and it will take you to the MySQL prompt. Here you create a sample example for doing the opposite law. Okay, if you type in this MySQL prompt, if you type show databases, it will show you all the databases. Okay, let me configure a MySQL. Okay, first. So please make a note, and then I will do the lab. No issue. So databases, it will list all the databases associated. So for your sample, you create a database. Use. Imagine if you don't have any database, let me create a database. Create database. Database name. Let me make it as 0. Then to connect with the database, use database name 0. Now you create a table. Create. Let me create a table, sample table, create table, employee with employee number, integer, comma, employee name as a string, comma, job as a string, comma, salary as a integer. Okay, let me create a table. And once the table has been created, you insert some data. Insert into the table name, values, you insert some data. 1, comma, employee name Ram, being it is a string enclosed in a quotes, comma, job is a DBA, and then salary is 9,000. Like you insert some records. You insert 2 to 3 records for our practice. This is what that we need to do for our MySQL. Okay, installation of MySQL and configuring the corresponding root user password and making a connection with this MySQL server. And then if you couldn't able to make a connection, you can check using the following services whether MySQL is running or not. If MySQL is not running, you want to invoke this MySQL using this service sudo system control MySQL start, and everything is perfect. You will be landed in this MySQL prompt. Under this prompt, you create the database and use the data connection, use a database name to connect into the database and to create a sample table for our practice. Okay, please kindly go through what we have discussed so far. If you then let me know if you have any doubt. Okay, sorry. So here the prerequisites what we did there so far, we have created a Hadoop cluster with either Hadoop 1.x or 2.x. On top of it, we have configured Java, Hadoop daemon, and Sqoop, MySQL connector. Being we are going to associate with MySQL, we have installed a MySQL database and associated connector, MySQL connector. In this, we are looking for a version 1.28. That version alone will work. So here we are now going to discuss about this utility of Sqoop import and Sqoop export. Using Sqoop import, what we are going to do, we have created a table, employee table in your MySQL, and we are going to import the employee table content using Sqoop from this MySQL RDBMS source. This is your data source, and this is your target. Your HDFS is your target. Using Sqoop, the data going to be crawled from this data source and to be placed into the HDFS. And once everything is perfect, you can do a process on top of it using a MapReduce program. Those programs can be written using a Java or Python or any other supported language, or you can make use of either Hive or Pig as of your choice. So once the process has been done, you have your data stored in your HDFS. If the data need to be stored back to your RDBMS, you use this Sqoop export command. Okay, so these are all the ways by using this import and export you can do the needed activity. First, let me start with how to make use of Sqoop import. So connect to your OS prompt. All the services need to be in the running state for this activity. So because since you are going to make use of this HDFS storage, your Hadoop need to run. Sqoop import. Okay, so hyphen connect. You want to specify the connection string JDBC colon MySQL colon double slash. Okay, what you need to do, being it is a single node, you can specify localhost slash. You want to specify the database name. Example, we have created a database by name through. This is your database name. To which database that you need to connect. This employee table was under a database by name through. You have created a database by using create database name, under which you connected to the database, and after that only you created a table. You want to specify the database name, localhost database name. After that, you want to specify your username, the root username. Then you want to specify the table, hyphen table. The table name is employee, and you want to specify the number of map. Okay, hyphen m is 1. That is number of map task that is going to be invoked to fetch the job. I will let you know what is map task. So it will start its execution, and it will make this Sqoop. What will do once this command has been issued, it will make a connection with this employee using this connect string JDBC MySQL. We have already configured this MySQL connector, and it will going to connect with this through database, under which it will look for a table by name employee, and it will take transferring the content of employee table and it will place in the HDFS. This is the way by which your Sqoop import command will do the needed activity. So here, by default, a Sqoop will invoke 4 map tasks to do a activity. If you want to transfer data from your data sources into HDFS, Sqoop by default will invoke 4 map tasks. Okay. So here, each and every map task will fetch the data, a partial fetching of data. So let me make this one. You have this data source. You have this HDFS. When you invoke this Sqoop command, you will be having map task 1, map task 2 by default, map task 3, map task 4. You already know what is map. Imagine this is your employee table containing 100 records, means the first 25 records, 1 to 25, will be fetched by the map task 1 and it will place in HDFS. The second record, 26 to 50, will be fetched by the map task 2 and it will be placed in HDFS. The third, 51 to 75, will be fetched by map task 3 and it will be placed. The fourth, 76 to 100. Okay, each and every map task equally transfer the data from the data sources concurrently. That is the key thing. And where it will be stored? It will be stored under this HDFS. So under the home path of your HDFS, the folder will be created under the name of this table. This is your table. That is your MySQL table. Under the name of this MySQL table, a folder will be created under which it will be stored under a file by name part-m okay 00000. This is the data fetched by map task 1. Then map task 2 fetched data, that employee under the same HDFS. This is under HDFS part. Employee part-m-00001 like 002 or 003. By default, it will invoke 4 map tasks. If you have a huge amount of data, if you are having 1 lakh record, so 1 lakhs of record, then if you want more map tasks to be invoked, what you need to specify? You want 10 map tasks need to be invoked. Each map task will fetch 10,000, 10,000, first 10,000, second 10,000, third 10,000 records concurrently. So if you want to do like that, you want to invoke the option -m10. In this example, we have invoked -m1 in our previous Sqoop import. Why so? Because since we have only 4 records or 3 records in our employee table, no need to invoke default 4 map task. Instead of that, what I am instructing here to Sqoop, being the record is very less, you invoke only 1 map task. That single map task itself is enough to fetch the data, being we have only less amount of data, and the data will be stored under the following location under a file. This is the name of the file. This is a folder. Okay, this is in HDFS. You know what is HDFS and what is LFS, all your people. Okay, this is the way by which your data will be brought into this HDFS and stored under this location. How you can check it? You know how to check. Command is move to the home path of Hadoop. cd home Hadoop Hadoop 1.2.1. From here, okay, you can invoke this command. bin/Hadoop file system first ls, you can specify root. You can find an employee table has been created. The same command. So bin/Hadoop fs-ls, if you specify /employee, then you can find this file part-m-000 will be listed. To view the file, what is the command? Again, bin/Hadoop space fs-cat, you specify the path. Under employee, you have the file part-m-000. You can find the data employee data 1 RAM, 9000 dba, like what are all the data that you have stored will be stored here, will be listed here. Okay, so then by using a hierarchy you can add a structure to the data and you do the needed process. This is the way by which here the data by default here it will be listed in a comma separated format. Please make a note. The data by default, when it is crawled by Sqoop and it is stored in HDFS, this part M-0001 is the file which holds the data, which contains the data in a comma separated format. This is the default location where Sqoop will store the data. Under the root, under the folder, it will store the data. Please make a note. So connect to this cluster. So this is the file that you need to download. Okay, Sqoop-1. In this case, Sqoop-1.4.5 is the file downloaded with respect to Hadoop 1.2.1. Here you can find this, the MySQL connector. Okay, please make a note. If you have downloaded Hadoop 1.2.1 and Sqoop 1.5.1, so the location is under this lib folder. You want to paste this MySQL connector. The downloaded file need to be placed here. That is MySQL connector Java 5.1.28 need to be placed here. Under the Sqoop home path, where you have configured Sqoop, there will be a lib folder. Under the lib folder, you need to place the connector. If not, you can't able to connect with your machine. That's important thing. Okay. Next, we are going to connect. So please make a note of this connector. Apart from this 5.2 1.28, if you try to use any other connector, it won't work. This is your single node. You observe what is going on. You try. If not, on tomorrow's session, I will try to install directly. No issue. This is my installed version. Now, after MySQL has been configured, you need to try to do this. Okay, this is my already installed session. So I will try to install you live tomorrow. So I want to make room for some spaces here in my system. I didn't have enough spaces. That's the reason why I want to show you how to install and how to make a connection, how to execute this command. So I am playing this video. Downloading the Sqoop. So it is your choice. You can download any version for Hadoop 1.x or 2.x. Both the version will work. So where to download? So under /home Hadoop. Okay, it will be a tar.gz file. So you open this and copy, and using wget you can download. Okay, from the mirror side what we have listed, nearby mirror. So duplicate, you want to specify the URL. Okay. So here this example shows you uh, downloading and installing directly into this Ubuntu machine. You can follow any steps. Either you can download into directly connecting to your Ubuntu machine's web browser, or from external browser. If you want to download, simply duplicate that URL, what we have discussed. No issue. Both ways you can do it. Then this file need to be untarred. You find a tar file. The file need to be untarred. tar-xvf, you need to untar that file. Then this path need to be specified under .bashrc. Okay, you can find under Sqoop, you can find a corner folder. Everything under corner folder only, you need to specify the Hadoop home path. Next, what you need to do, you want to untar and you want to populate it. That's all. So please make a note of this lib folder. Okay. So you want to be careful before downloading and place this MySQL connector Java. That is very important. Jar file. For Oracle, we have Oracle connector. For SQL Server, for each and every databases, there is an associated connector. Here, being we are going to make use of as a source database as MySQL, it is MySQL connector. So this is the location where you need to download this jar. Okay, you want to save the file. You please make note of this menrepository.com where we have downloaded men repository. Okay, men stands for Maven repository. Yes. Now, so warning. Okay, sorry. We have not enough space. That is the reason why I couldn't able to install separately. You will find that here you want to specify. Already you have this bash rc file. In your bash rc file, you have Java home, Hadoop home, Hive home, Pig home, and you want to type Sqoop_home and followed with under the path you want to specify the Sqoop home path and bin folder. Okay, this is what that we need to specify in your .bashrc file. Then source the bashrc. To make the change applicable, you want to use the command source bashrc. Either you can type .execute or source bashrc. Both the command will hold good. Okay. So this is what how to install Sqoop. Okay. So we will install this Sqoop separately and tomorrow by removing some files here. I didn't have enough space in my hard disk. Everything was full. Okay. If I took a C drive, it will show you it will having only 500 this much of MB. That is not possible for us. That's the reason why I couldn't make it. I will make room for some free space and I will try to install. Now this is, you try with what are all the things that is shown to you. You please try with. If not, I will support you. Next, how to let me continue with the associated commands with Sqoop. Let me continue with the associated commands. Next command. So by default, if you invoke this import, it will store under the root folder of your HDFS. So I am interested under HDFS. I am having a folder by name. Okay. So let me make it as a MySQL. Under this folder, MySQL database tables. So this folder is already existing. For example, I need to store all the tables under the folder. And how I can specify? That is how to import data into a specific target folder. How to import data into a specific target folder. Import to a specific target directory. The default will be under this HDFS, under a root folder. What is the name of the table? Under that name, your data will be imported. Now my intention is to store this table under this specific folder. How to make it? Please make a note. The command is Sqoop import. All other things are same. Okay. You need to specify that -- target directory. That's all. So you specify -- connect. You want to specify a connection thing. These are all common for all commands. JDBC, MySQL, being it is a single node local host. / you want to specify the database through. You want to specify -- username, root. One important thing, you can continuously type in your prompt, operating system prompt that you got connected. If not, if you want to break, you want to use this symbol. Okay, if you want to break and to make it in another line, simply / enter key, it will take you to the another line. So it shows that it is continuing in the next line. Please make a note. You want to explicitly specify this. Okay, to let you continue this command in the next line. -- username root -- table. Once again, the table is employee. That -- map task 1. Here, what you need to specify -- target directory. You want to specify the target directory. It is under MySQL / database tables. What happened here in this case? Once you issue the command, this employee table will be stored under the target directory. Under this, you will be having port -m-0000005. Please make a note. This is the way by which you can have an explicit option by name -- target directory to store the data into the appropriate target location. How you can check it? You can check it by using the simple command, the same command. Okay. Move to this Hadoop home path /home /Hadoop -1.2.1. Okay. So from here, use this command bin / Hadoop file system -cat. You can view the file /MySQL /db tables / you want to specify port -m-000. Okay. So this will list you all the data associated. So here, please make a note. Now we are going to discuss how to import a data based upon certain conditions. Import based on condition. So I am having the table employee table with employee number, employee name, salary, and I think so job. I need those people getting salary greater than 10,000. Alone need to be inserted. How I can make it? Import based upon certain condition. Condition based import. All other things are same. Sqoop import, connect, JDBC, local host, username host, table add, -m. Okay. Here you want before this target directory, here you want to include this line -. The condition need to be specified as where condition. How you will execute this query? Select this star from employee, normal in SQL, star from employee, where condition is where salary greater than 10,000. Similarly, here after specifying this -map 1, you want to specify where you need to specify the condition. Okay, where salary greater than 10,000. That's all. Okay. You can enclose this condition under a double quotes where salary greater than 10,000 target directory, the target directory. So only those records which satisfies this condition alone will be listed. This is one of the okay. So next. So we have imported only one table. Imagine your Thiru database. This is your database. Under Thiru, you have multiple tables. Under Thiru, it is assumed that you have multiple tables. You have employee table, you have department table, so you have multiple table, employee personnel. Let me make that you have three tables, employee, department and employee personnel. You want to import all the tables. You want to import all the tables. How to import all the tables? Rather than specifying on table, you want to import all the tables. Okay? Then simple command. Please make a note. So up to this, it is the same. You no need to specify this table, everything. Okay? Sqoop import, here what you need to specify, you want to specify instead of import -all table, that's all. You want to specify here import -all tables, that's all. Okay, import -all tables, connect string JDBC : MySQL localhost through, this is the database name. Okay, username root, that's all. You no need to specify the table name. The keyword is import -all tables. So all the tables under this will be, you can make a check. Okay, by simply typing, so that bin slash Hadoop fs -ls. Okay, under root you can find the table employee, the table department, and the table employee underscore personnel. So under each and everything you have this part -m-000. This is the file part -m-000. Okay, this is the file which contains the data. To try with some 2 or 3 tables, to create 2 or 3 tables and try to use this import -all table commands to check whether it is properly imported or not. So next we are going to discuss about export table. Very simple. So we have lot of options associated with import that we will discuss on tomorrow. Now to end up with the session, let me discuss how to export the data. So you have in your Hadoop, so under this folder, okay, let me make it as under employee, you have part-m-000. This is under your HDFS. Okay, here you are having your MySQL. Under MySQL, you have this through database. You have an employee table with the employee number, employee name, salary, and job. Imagine you create this table with the following field. You know how to create the table. Okay. So here you connect with this MySQL. First, for this practice, you connect with this MySQL and create a table with the opposite. Use database name. Use Thiru. It will take you connection to the Thiru. Create table. Let me make the table name as employee. So here you have employee number. You have already the table. If not, you create the table. Employee number, integer, comma, employee name, string, comma, salary, integer, comma, job string. For string, S is capital letter. Okay, please make a note. That's all. So you create a table. Now you have data stored in your HDFS. What you are going to do? So now this HDFS is your data source. HDFS is your data source. Then your RDBMS is your data target. You are going to bring the data and store into the table. What is the command that you are going to make use of it? For that, you are going to make use of Sqoop export. Okay, this is the scenario. So you issue the command Sqoop, connect to this OS from Sqoop export space. You want to specify the connect string hyphen the same connect string JDBC colon MySQL. Okay, double slash you want to specify, I am continuing here, localhost slash, you want to specify the database name, then you specify your credential hyphen username root, you want to specify the target table hyphen table, the name of the table is employee, you want to specify the direct hyphen export hyphen directory is equal to /m. This is the directory that you need to specify. This is your directory, the file containing in the directory. So assume that you have file 1, RAM, 9000, db. Assume that the data stored in the file is in comma separator, as I told. This files, once you issue this export command, this data, the corresponding data will be fetched and it will be placed here. 1 RAM 9000 and db, and you can make a check after executing this command. Connect with MySQL. In the MySQL prompt, okay, you in this MySQL prompt select start from employee means, so it will list you the data associated with the employee. This is the way by which you can make use of this Sqoop export command to export the data from your HDFS and to place the data into your MySQL. So here our discussion on how to create a MySQL table and how to configure Sqoop and how to do import and export is over by today. So we have a lot of options associated. We did a simple example. So we have lot of options, real-time options associated with that, just performing an incremental import export like thing. So how to improve the efficiency, okay, by importing or exporting data, by compressing the data. So how to invoke the number of mappers like thing will be discussed on tomorrow. Tomorrow our session will be from morning 8:30 to 11 a.m. Okay, I will share you the link for 8:30 to 11 a.m. So we will have our session. We will continue our session on Sqoop And once the scoop has been over, we move back to our discussion on Hive dynamic table, Hive partitioned table. That's the thing planned for the next session on tomorrow. So before winding up this today's session, if you have any doubt, please let me know. Now, tomorrow's session will be morning 8:30 on Sunday 8:30 a.m. to 9:30, 10:30, 11 a.m. Okay, we are going to continue this scoop. We will complete the scoop and followed with we also complete your Hive dynamic partition. This is the agenda for tomorrow's session, Sunday. Okay, Abhilash, you can, if you have any doubt, you can converse you now.